Hi, everyone. Welcome to this webinar on accelerating ingredient discovery with AI. In the last few years, there have been these significant breakthroughs in information discovery using AI. And today, the potential for faster research iterations, reduced timelines, and shorter time to market is among the greatest that has ever been. Recently, L'Oreal patented three novel ingredients that were discovered using AI. And according to them, what once took 7 years was achievable in less than a year. Likewise, Unilever is now using AI to map millions of enzymes and molecule combinations and coming up with novel solutions. In our conversations with over 150 R&D leaders in the cosmetics industry, we saw a similar sentiment to leverage AI to optimize and supercharge their ingredient discovery. Typically, the triggers that drive ingredient discovery are the three most common ones, like there could be a regulatory push, there could be changing consumer preferences that reshape research priorities, or there could be an internal mandate, maybe a breakthrough innovation that has happened internally, or maybe a sustainability initiative by the organization. These tend to be the triggers that drive a change in ingredient discovery or the need for the same. In today's webinar, we will discuss how AI can transform ingredient discovery, regardless of whatever is the source that is driving the need for that change. We will discuss why the traditional methods and the general AI tools often fall short, especially for corporate R&D. We look at some of the real-world use cases of ingredient discovery through AI across the R&D life cycle. And finally, we will have a live demo of AI-led ingredient scouting that has actually helped teams boost their technology reviews from 2 to 10 per month and has helped them make research iterations around 3 times faster. With me today is Anmol, the technical architect at Graby, who himself has been a researcher for a large part of his career. And I am Regina. I am the product manager here at Graby. And today, the two of us will walk you through some of the prominent and promising use cases of AI for ingredient discovery in the cosmetic space. When looking for information and state of the art, a lot of time is actually spent on what researchers called researching the research. So almost 80% of the time is actually spent in just identifying the best known idea, whereas only 20% is generally given to analyzing that information and doing the strategic work that would lead to the upcoming innovation. Now, the reason for this is that the traditional methods of discovering ingredients actually are quite complicated, require mapping of properties and various constraints across multiple databases. So, generally, what such a traditional search looks like is endless tabs open. You have partial data coming in from everywhere that requires stitching of all of that data. And oftentimes, you are compromising between speed or depth. And actually, I'd like to get some insight from Anmol here, who has been someone who's been hands-on with this kind of research. Anmol, what were some of the challenges that you faced when working with these kind of databases?
Uh, there were a lot of challenges, but I would say the prominent ones were how I used to go to each of these sources differently, design few keywords, come across few of the research papers, and then understand more like, there are other keywords that I was missing. Then I could refine my search again. So this loop was keep on happening just to find the papers. I would still have to, read the papers in detail. So I would see 100 plus tabs easily opened for the things that I want to read later. And then when I started reading them one by one, then some of the papers they were mostly junk. They had claims which I knew were not reliable, and I can easily look up at the authors or the institutions through which they were being published, and I can easily figure out that which I should prioritize or not. So eventually it was a lot of first keyword gymnastics that used to happen on a lot of tools, and then too many back and forth until the browser crashes because of too many open tabs. That's how the ingredient discovery would usually look like.
And surprisingly, this is how it has been up until very recently. And even right now, for a lot of teams, this is what the reality of discovering new ingredients, discovering new information for R&D teams looks like. But the real cost of this is not just the manual effort or the lot of legwork that research teams have to do. The real cost is much more magnified at a larger level. We are talking about information overload here. There could be potential blind spots because you're so focused on one aspect of research, you could be missing out on multiple other directions, which inevitably leads to duplication of effort then. Same teams redoing the same kind of work in the absence of open visibility of information. And particularly in ingredient discovery, this means more trial and error. A lot of time is spent in just figuring out the right kind of ingredient, and if there's not enough data to support it, you take it to the labs, it does not fit the requirements, it is not what you had intended to what you set out to look for, and eventually there's this repeat cycle that just goes on. All of this culminates into longer time to market, which in a fast moving space like a cosmetics industry can actually mean the difference between leading a particular space or simply following suit. So the real cost of slower discovery is actually much more magnified and translates to longer time to market. Now, traditional databases fall short because they were never built for that kind of information discovery, never built for that kind of mapping. But even the generic LLMs that exist right now are not the right kind of solution, mainly because of three reasons. First is that the information that comes out from these generic LLMs is generally not credible. The sources that it pulls the information from can oftentimes be the general web and even hypothetical in nature, as has been the case recently. Secondly, they lack the expertise. Even if the information that comes from these sources is credible, it does not replicate a researcher's workflow, and it often glazes the information, simplifies it for the sake of summarization, missing key details. And most importantly, for corporate R&Ds, these systems compromise security. Most of them do, because you do not know where your data is going, you do not know how it's being processed, what it is being used for, is it being used to train the system, and that kind of lack of confidentiality is a non-negotiable for research and development teams at enterprises and at high growth companies. Anmol, what do you think about the generic LLMs, which we also often call as horizontal LLMs or horizontal AI models, compared to what is upcoming in the industry now, which is more of a vertical or more of an inclination towards vertical solutions which are built for
Yeah.
industries? So
Yeah, I think a lot of industries adopted these horizontal AIs because these were I would say the first wave of AI when came. These were the tools that were at everyone's disposal. So everyone started using these tools. It seemed like how, I think 20, 30 years back, everyone used to do everything in Excel. Then a lot of specialized tools came into place, where you don't have to do everything in Excel. There were specialized tools. So in the same way, in AI, the second wave would be the vertical AIs. These are the AIs that would be hyper specialized in one task, but they won't be very good in the other task. We have already seen a lot of progress in this direction, like the protein folding models from Google that are specially designed for figuring out the structure of proteins. It doesn't write emails. It can't do the brainstorming with you on other topics, but it can figure out the protein foldings very well. So we call them vertical AIs. In the same way, for the ingredient discovery, for the simulations, for the lab testings, we'll see a lot of vertical AIs coming up, and these will be the AIs that would be hyper specialized to do one particular task and will bring more depth, more quality out of the results that are being produced by these models.
Right. Absolutely. Absolutely agree with you. And when we talk about horizontal versus vertical AI, this is what the comparison looks like. Generally, when we talk about the depth of search versus the speed of search, manual search performs very well when it comes to going into the nuances, given that you have the time to do that. But time is oftentimes the biggest constraint. So, manual searches in a corporate setting can delay the whole process significantly. Then, if you go for generic AI tools, they will give you the speed, but that speed comes at the cost of redoing the work again and again because the depth is missing. So, you oftentimes have to verify the sources, go back to where the information is coming from, and fill in the details, fill in between the lines here to come up with a foolproof solution. It is here where the specialized AI tool are perfectly poised for R&D teams because they provide you that absolute balance of speed as well as depth of search. So now when identifying these kinds of vertical AI tools or specialized AI tools, there's a certain checklist that a lot of R&D teams are building now. This is something again that has come out as part of our discussions with R&D leaders, R&D teams. So they'll start by looking at data credibility, which is the most important thing to begin with. Where is the data coming from? What are the sources behind it? Followed by, is it just a list of documents that you would be provided, or some insight from them, or some intelligence from them? So, are the results decision grade and not just a document dump? That's another evaluation criteria. And at all times, you're looking for not just breadth or not just depth, but both, because AI can optimize for both. So, that is the third criteria, oftentimes used by research and development teams. Then, what teams also look at, other than what the system provides internally, are some external capabilities. How well does a particular solution fit into their workflow? So, if it's a team of formulation scientists who are discovering ingredients, are they only able to identify literature for the same, or are they also able to save and store all of this literature and maybe then pass it on to the innovation team or other teams and collaborate with them on the same? How well does it fit into that kind of workflow? Does it offer customizations? Let's say you want to focus on only peptides, or you want to focus on only alternative plant proteins. That is your focus area. Are you able to customize your data sources to look into only these kind of sources so that you eliminate the noise? And finally, as part of this evaluation checklist, the most important bit is the security and compliance. How secure are these solutions? What are the standards that they adhere to? It's very important for corporate research and innovation teams. And eventually, this becomes a big bottleneck for a lot of them in adopting any solution which is right off the shelf. So these are some of the evaluation checklist that most R&D teams are using to find the right kind of solution.
Yeah, we have often seen a lot of researchers or the teams while making decision, they are often figuring out how to compare since there are a lot of solutions in the market. So we have also designed a checklist that ideally should help you in figuring out which solution is best for your kind of work. So you can simply write checklist in the comments, and we'll be happy to share the spreadsheet with you.
Absolutely, absolutely, we'll do that. So, as part of this webinar, we'll actually now look at some of the specialized use cases of vertical AI for ingredient discovery across the R&D lifecycle, starting from early stage R&D, where we look at how AI can be used for superfast literature review, mapping ingredients, their properties, and identifying the right kind of solutions which meet specific constraints, to conducting technology and landscape and competitor landscape reviews for ingredient based technologies, and to finally finding solutions to more specific problems which could be constraint rich and have multiple trade offs involved. oftentimes the problems that come into the picture when you're maybe a formulation scientist or someone working on a new product. So across the entire R&D life cycle, we'll walk you through some of the prominent use cases, and Anmol will show you how all of this is achievable through vertical specialized AI.
All right, so we'll be running some of the problems that usually come up during the alternate ingredient discovery, and we'll see how vertical AI ideally works and how it can simplify or accelerate the whole process. So this is called Slate, one of the solution that can help you with the alternate ingredient discovery. The interface is super simple. You have to just interact with it in a natural language like you would do with other horizontal AIs. For example, here I have executed some of the questions to save some time. Okay, so maybe here one of the researcher wanted to know, like, what new bioactive peptides are being explored for anti-aging formulation. This is the problem on which I'm working. So here what the system will do is, instead of giving me the answers or instead of giving me the results that I can go and figure out myself, it will see if there is a lot of research happening in this area, recent research. Since this is state of the art study that I'm doing, it will figure out that if there is a lot of research happening in this area, instead of giving me answer, it will give me the potential directions that can be pursued for solving this problem. So here, what you see on the screen, the system has done, the vertical AI has done a mini tech landscape of the solution space, and the bigger card size denotes how much recent research is happening. So this is equivalent to research velocity that is happening. Bigger card, more research. And this, oftentimes I have heard from the fellow researchers that this acts, first of all, this acts as a blind spot remover, which means there are certain solutions or the directions that have been shared by the system that they were not aware of. So this also becomes kind of a knowledge discovery during the process of alternate ingredient. Secondly, they have often told me that this becomes very useful when they have to build the roadmaps, because now whatever is coming on the screen, this is backed by the evidence, this is backed by the research that is happening in their area. So the roadmap of the product or the formulation that they are trying to achieve, it can be more evidence backed or data driven. So two major problems that are being solved by this heat map. So if I select any one of these, the system will again see if there is a lot of research happening, or if the query is too nuanced, then it will give me a tabular instead of the research papers in first of all. So this is the same table that I would usually generate while doing such kind of studies to see, what are the key areas, what was the source, whatever dimensions across which I want to compare. I usually end up with this as the final comparison matrix usually. So the system, we have coded the system in the same way so that this AI gives the output in the similar manner as eventually you would build after analyzing the top papers or the patents. And you can also add your columns as per your requirement, and it will do the full text analysis. It will read the full text and figure out the columns. This is being followed by a review paper to get my understanding. This has been very useful in my research now, because whenever I have to do an executive summary or I have to send a brief, I simply share this review paper with the stakeholders so that they can get an understanding of the overall landscape of the solution. This has been very helpful for me. And within this, if you feel, say, one of the solution looks promising, say pea and rice growth promoting peptides, this looks promising, I can click on this and I will be directed to the exact source in which this has been discussed. I can have read the quick summary which contain all the relevant technical details for me. And if I feel this looks quite relevant and pique my interest, I can click chat with paper. So now what the system will do is it will load up this whole paper. In this case, this was a patent, and I can chat with this patent and do the grilling, ask the cross questions, maybe ask like what are the limitations that has been disclosed into this particular patent. But the idea here is that the whole research journey gets covered here, where you start with a broad question, you get a tech landscape of the solution, followed by a literature review and a review paper, and then you can go to the particular topics or the citations that are looking promising, and you can start chatting with this particular patent to get the questions or the answers. This is usually how the workflow looks like.
Also, Anmol, on that note of the heat maps that you showed, I'm actually reminded of one of our conversations with one of the users of this platform, who called this an executive snapshot of research and innovation in time. So, I mean, a single glance at this, and teams can identify that within anti-aging peptides, the food and marine sourced antioxidant peptides have the most amount of research and innovation activity happening at the moment, followed by collagen boosting derivatives. And then there is these MMP inhibiting and anti-inflammatory peptides. So a very dynamic visualization of the research landscape, which gives you ideas in a way that was not earlier achievable. So, I mean, just the visual representation of the data that has always existed can make decisions easier and more data backed, and this is something which is a testament to the same. So yeah, that's definitely an interesting use case.
Yeah, and one of the activity that I usually perform is every quarter I would come to the system and run the same query, because I could see how the blocks are moving, and that could validate whether we have picked the right direction or not. So this also helps me with the course correction, because every quarter I can run the same query, but the answer would change because it focuses on the recent things that are happening. So very kind of a compass, you can say, for directing us in the right direction have been useful for me at least. So one of the other criteria in which I used to look for the formulation is, I would say, what are the leaders in the industry on which I'm working, and I will see how they are solving some of the problems, or what are the ingredient or the things that they are publishing. So for example, you want to see how L'Oreal is using the ingredients in the anti-aging formulation. Usually this analysis would take weeks to do, because you will find all the research by L'Oreal, patents by L'Oreal, their subsidiaries. Then you will see through keywords or some other ways how many of them are from anti-aging, and then you will shortlist some of them, and then we'll read the paper one by one to extract the formulations, because I'm just concerned with the formulation. So this will usually take a weeks to perform if I would use the traditional tools. Here I will simply ask this question, and the system will automatically figure out all the patents or the research of L'Oreal that is on anti-aging, and it will scan the full text and extract the formulation that is required to me. So within a query, I can see, or I can get the answer very quickly. I can, of course, go back to the citations in the similar manner, do the grilling, do the debugging, or follow the research trail. But the idea here is that the information surfacing of the alternate ingredients becomes super easy, and you can spend more time in isolating the prominent candidates, formulations, alternates, so that they can go into the next phase. It could be lab testing or something else, but this helps in the very quick uh, information discovery.
What's interesting is also how here the core active ingredients are tied to the formulation delivery system. I mean, if we look at the table, how the comparison has happened, and we can actually see the composition of the active ingredients, then how it's tied to the delivery system, and what is the claim that this particular patent by L'Oreal is making. So all of that kind of information mapped in this sort of format makes decision grade outputs more easier for teams to identify. I mean, generally, as you highlighted, Anmol, typically for teams, this would take what, easily maybe 2-3 weeks to prepare, but
Yeah.
easily here it's achievable in what, a matter of few minutes to few hours. So that time saving is significant in terms of innovation and research discovery.
Yeah. And I also have questions from the chat. Let me copy one of the questions from chat and run it here to see what
That
kind
should be
of,
interesting.
yeah. So this is on, the titanium dioxide uh, alternatives, because a lot of regulatory push is coming up onto this. So the question is like uh, recent titanium dioxide free sunscreen compositions. That's what the question is. So I'll let it run here, and maybe I can, meanwhile this is loading up, I can show few other scenarios in which I use this system to figure out things. So one of the uh, other area is where uh, I could do the cross-industry solutioning, because I find it very fascinating that you can pick a lot of solutions from the cross-industry, apply into your area, and that usually works because that is oftentimes a underlooked area. So this system can also help you with that. So for example, here I am picking the solutions from the food industry, and which can be adapted for enhanced skin barrier repair in cosmetics. So all the solutions now, the system that will come up with be from food industry, but which has certain applicability in the cosmetic. So this is another area in which I use the system heavily when I have to find some novel solutions and I feel I have exhausted the research surface within my domain. So oftentimes I would input other industries that I feel should have this solution or should be working on such kind of problems. And I sometimes I do come with certain novel solutions that can be further added to the research pipeline. So this is another use case where you can ask the system for cross-industry solutions, and it will do the heavy lifting of doing the literature review or finding the alternatives in those situations also. All right, so meanwhile this is working to find the results. There is one area in which I use it very heavily, and that is when I have to find certain solutions, but those solutions are defined by very strict boundary because they are now deployed or they need to be added to the production pipeline. So oftentimes we have seen there would be a lot of constraints because you cannot simply eh, you know uh, simply add or remove things from there. A lot of suppliers are involved, existing inventory is involved, ingredients are involved. So a lot of constraints do come up, and sometimes it could be regulatory constraints also. So in those cases, I use the module called Prism. This is specially designed where you have a lot of constraints and you want the solution or the answers to be within the defined boundary. You cannot run the free form search kind of. So I'll define the boundary here in this situation, and the system will ask certain counter questions. Once it feels that it has enough context on what you are trying to figure out, and what it will do is it will start doing the formulation. So there are multiple agents now involved, very small agents involved here that are specialized in one particular task. So for example, certain agents, they just do the formulation, that what are the inclusion or the exclusion parameters, what's the boundary. Then few do the literature search, then there are certain who do the relevancy search, full text analysis, then figuring out the evidence that can be shown so that I can trace back from why that solution is coming up. And interestingly, this was part of the thing that we do as a red herring team internally. So one of my colleague researcher, whatever promising solution that I would flash to him, he would always come up with certain studies that would negate the claim that has been made, which means he will always come up with the contradictory studies. And it has been become a practice for me to show the solution to him, and he would come up with the certain objections to that solution. I would evaluate the solution. That becomes part of the habit. So we also added the same agent over here, where it will figure out the contradictory evidence for the solutions that have been figured out by the system. So during this evaluation, it has scanned almost 17,000 documents in this whole process. It takes around 1 hour to do, 30-40 minutes, sometimes even 1 hour. And then I will be given with the solutions. These are the solution, novel solutions, not the research paper, not the patents, but the actual solutions that can be deployed along with the evidence supporting documents that I can study further. So high fidelity means all the constraints that I have defined, they have been met through these two solutions, and then there's moderate fidelity where I have to do some lab tests to figure out some of the constraints as they are not meeting. Approximately half of the constraints are met in this. But this is another use case where whenever I have to run the production pipeline, I have to put some solutions into the production pipeline where a lot of constraints are involved. I often use this module called Prism to run these kind of searches or ingredient discovery.
So, if I understand correctly, we've effectively gone from just literature searching and review to solution mapping now almost. So these are like potential solutions which could actually be tested or maybe moved to the lab and testing stage, right?
Yeah,
So then that's definitely interesting, and I see a use case for teams like maybe formulation scientists, people who are working with specific constraints in new product development. Let's say you're developing solutions using retinol, which needs to have a particular shelf life, which needs to have certain stability, should be usable in a particular temperature range. So for constraint-based questions like these, a module like Prism could definitely come in handy.
yeah, absolutely. And oftentimes we have seen a lot of teams before they conduct a full-fledged search. This often comes as a prelim solution surface scanning, where they understand like whether there is a possibility of certain solutions coming up if they do a full-fledged study. So this also helps in building the confidence for those kind of situations. I think the
Right.
answer for the question that has been asked is here. Let me jump over to
Oh,
this tab. Okay, so here was the question that I picked from the chat: recent titanium dioxide free sunscreen composition. So here are the uh, compositions that the system came up with, in which year it was published, who was the person, particle size, concentration, key innovation, and I can go through these very quickly to understand what are the potential directions in which I can start removing the titanium dioxide from the sunscreen, which means it will, all of these compositions will already have the sun protection and all the mechanisms that are required in the sunscreen. So we'll share the link over the email also so that you can go through the results. But essentially, that was how you can use a vertical AI like Slate in this case to come up with the alternate ingredients and accelerate the information discovery very quickly.
thank you, Anmol. That was some very interesting use cases, some very interesting use cases of how AI is used across the R&D life cycle for ingredient discovery, be it for searching novel ingredients or looking at competitor innovations, to then solving very specific challenges which might arise as part of optimizing existing products or as part of new product development. So these are some of the use cases of AI which we discussed today, along with why the general AI tools generally fall short for these specialized use cases. And if you are evaluating AI products, then what is the checklist that you can keep in mind as a baseline for selecting any vertical AI tool for your R&D teams? I hope this was insightful for all the attendees here. Additionally, we are giving a 30-day access of Slate to all the attendees here. You can sign up at slate.graby.com. We will also be emailing the link of our website to all of you, so you can also sign up using that. Thank you again for joining.